In this video, we'll be doing the question you see on the screen from the 2023 Leaving Cert Higher Level Maths Paper 1. If you're looking for a different question from this paper, there should be a playlist in the description below. And if you're looking for a different paper entirely, have a look on my channel. I'll be doing all of this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we are on YouTube, so take advantage of that. Pause, try the question first, and even change the speed of the video to half speed or 2x speed if that's your thing. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, or especially sharing it with someone else you think might help. It might help. Question 9 starts off by asking us to list the 5 different factors of 2 to the power of 4. You don't have to multiply out 2 to the power of 4, but let's do it just to help us think about it a little bit. This is equal to 16. So it's a small enough number that we can just go through every possible number. Does 1 go into 16? Yes. Does 2 go in? Yes. 3, no. 4, yes. 5, no. 6, no. 7, no. 8, yes. And nothing else until 16 itself. They're the 5 factors. Just one more thing, they did ask us to write all of them in the power of 2, sorry. So 16 is 2 to the power of 4, 8 is 2 to the power of 3, 4 is 2 to the power of 2, 2 is 2 to the power of 1, and the slightly hard one is 2 to the power of 0. That's the answer to part 1. What they're trying to help you see here is that 2 to the power of 4 all of its factors are just 2, 0, 2, 1, 2, 2, 2, 3, and 2 to the power of 4 itself. Okay, that's what they're trying to show you here. And that leads on to part 2, where they give you a much bigger number, 3 to the power of 7. 3 to the power of 7, I'll put that into a calculator. And that comes out as 2,187. You could, if you spent 5 or 10 minutes, just go through all the likely numbers and get the factors of this. But what they're really hoping you do, they hope you don't spend those 5-10 minutes. What they're hoping you see here is that the factors are the same as this. The factors are 3 to the power 0, 3 to the power 1, 3 to the power 2, and so on. And really, they don't ask you to list them, they just ask you how many there are. So they want you to see the pattern that there's 5, 2 to the power 4, there's 8. 8 is the answer here. I'll just say a little more about it. And this is the same as, let's see, 7 of them. 4, 5, 6, 7. 7 trees. What's actually happening in here is the only factors of this number, these are all multiplied together, by the way. The only factors of this number could be if you'd have to break these numbers up more, or they themselves. So like 3 is a factor, 2 of the trees is a factor. 3 of the trees is a factor, and so on. And you can't break up a prime number, and that's what 3 is, and that's what 2 is. You can't break it up except for 1, and that's where we get this 2 to the power 0 out. Okay, otherwise there's the only factors of this is 3 on its own, 3 by 3, 3 to the power of 3, 3 to the power 4, 3 to the power 5, 3 to the power 6, and 3 to the power 7. And then the only extra one is a 1. So that's the only way you can factorize a prime number. That's what they're getting at here, and I just wanted to try and explain that a little. Then in part 3, they want you to put this information all together, and they give us, what's it, 2 to the power of 10 times 3 to the power of 12. I haven't even bothered putting this into a calculator. It's a pretty big number. How many factors does it have? The best way to think about that would be, I think, this idea here. So let me just write that down slightly. I meant to write 2. So 2, 2, 2, and this stays going on. There's 10 of these. 2, 2, and then 3, 3, and there's 12 of these. 3, 3. So think about what factors of this there are. This is one big number when they're all multiplied together. Well, 2 is a factor. 2 times 2 is a factor. Basically, this had 11 factors and this had 13 factors. All 11 factors of this is also a factor of the bigger number. You could think of that like 12, 3 and 4 are factors of that. But so are the factors of 4 itself, which is 2 and I guess 1. if you're a factor of something that's a factor, you're a factor. I don't want to confuse you too much, but that's basically what that's saying. So all 11 of these factors are factors of the big thing. 13 of these factors are also factors of the big thing, although there's something tricky there I'll talk about in a moment. But the only other thing is there's more factors. There's a lot more. 6 is a factor of this big number. Because look, 2 multiplies by 3 is inside this, so 6 must be inside the big number. And there's loads like that. So there's 2 times 3, 2 squared times 3, 2 cubed times 3, and so on. There's, I guess, 10 of them, because there's 10 of these 2's. So that's an extra 10 factors. Then what about 2 times 3 squared? 2 times 3 cubed, 2 squared times 3 squared. 2 cubed times 3 squared. There's loads more factors. That's another 10. And so on. You could do these for 3 squared, 3 cubed, 3 all the way up to 12. There'd be 12 of these 10s. So there's 120 factors in this way. So that's 120 plus there's this 11 plus there's this 13. All that adds up to, the wrong answer by the way, 144. And let me just double check that is what they add up to. And now the question is, why is that wrong? What have I done wrong there? Hopefully I've shown all 120 of these are factors. They're this big mess here. All 11 of these are factors. All 13 of these are factors. But we have to take one away from this number. And pause it, think about why that is, where does it come from. I've used the same number twice. These 11 factors, one of them was the 1. Remember that sneaky 1 we added on? That 2 to the power 0 we added on. And then 3 to the power 0. They're the same thing. 2 to the power 0 and 3 to the power 0 are both 1. I counted the same factor twice up there. So the real answer is, take 1 away, and it's 143. That's the answer to this part. Tricky question. Don't beat yourself up too much if you don't get it. It's a weird question, but it's a good, interesting maths one, I think, anyway. If you have any follow-up questions, let me know in the comments. I'll do my best to answer them. So on to part B. In part B, they tell us that someone is exploring the factors of 12, the pair factors of 12, and they've drawn this table. So that's, they say there, x times y equals 12. What are the numbers for x and y? And there's only one of these that's complete, 3 and 4. So 3 times 4 equals 12. They want you to fill the rest in. If x is 1, remember x times y is 12. What's y? Well, it's 12. If x is 2, y must be 6. If x is 6, y must be 2. And if y is 1, x must be 12. And they've left 1 out. X can be 4 and y can be 3. That's all they wanted to do there. And for part 2, they have a graph like this. I won't bother putting the numbers in. You don't need my exact answers. And I can't quite see there, but they have one of the numbers already in. I assume it's 3. So a 3 here and 4 here. They have a dot in there. They just want you to fill the rest of the dots in. So at 1, they want you to put a 12 in. I'm going to rub this dot out just because I think it's in the wrong place. At 1, they want a 12 in. At 2, they want a 6 in. At 3, they want a 4. At 4, they want a 3. At 6 on the x, they want a 2. At 12 on the x-axis, they want a 1. They want something like that. I know what the shape's going to be, so I've just drawn that. And then for part 3, they want us to use this again. They tell us Ava is the girl that's doing this. She realizes the relationship between x and y is equal to 12 over x. Don't know why I'm looking, because obviously it is. X times y is 12. Divide both sides by x. We get y is equal 12 over x. On this diagram, they want us to draw a graph of this between 1 and 12. Sounds like a really hard thing to do, a lot of work to do. The thing is, this is the same as this, which gives us these numbers. We already have the dots. All they want us to do is fill a line in, a curve, I should say. a curve between them, and we get this sort of curve that goes presumably off to infinity and never touches this axis. Well, that's what it does, and it never touches this axis, goes off to infinity. But they just want it between 1 and 12, which that's all it is. Then part C continues on with this y is equal 12 over x. So I'll keep this here. Yeah, we'll put C here. Because we'll talk about the graph a couple of times. So y is equal to 12 over x, but there's a point P 12 over P that's on this axis. So just think about that. Imagine if it was 3. P was equal to 3. 3 and 12 divided by 3, which is 4. And we know that's on it, 3, 4. But this could be any number. It might be 2.7. It might be 94.3. It could be any. It could be pi, and 12 divided by pi. Any number. They want us to show that the equation of a tangent of this point. So if it's this point, the tangent would look like. We grab a stick here. A tangent on this, but we just don't know what the point is. So it could be this. It could look like this. It could be all the way down here and be nearly a flat line here. We don't know what it looks like. Depends on P. But they want us to find the equation anyway. And they've given us the equation. Show that this is. I won't write it down because I find it's sometimes more useful not to. When they say show this, don't try and use it. They want you to discover it, and then you use it to check if you're right. If you need a few hints from it, that can sometimes help. They basically want us to find the tangent of this with this point. We can do that. The tangent of a line. Let me write the equation. Y minus y1 is equal to m multiplied by x minus x1. All we need for the equation of a line is a point. We have a point. And a slope. That's the harder bit. How do we get a slope? You should think slope differentiation. We have y. We want dy dx. Before I do this, I often, whenever I have divide by x, I like to change it. Y is equal to 12x to the minus 1. No different, just a different way to write it. It's just, I think students find it easier to differentiate this than this. Because the same rules apply then. This is 12x, take 1 away, minus 2, but the minus 1 multiplied out front. So minus 1 multiplies, that's there. And then we can if you want to write it back like this just becomes minus 12 divided by x squared. That's it, that's the derivative. If we want the slope at any point, all we need to do is put the point we want in here. So m would equal dy dx at a certain point, at the x equals, in this case, we're interested when x equals p. So that's just equal to minus 12 over p squared. That's what the derivative tells us. So we can just fill out the equation of a line now. Y minus y1 is here, 12 over p is equal to the slope. The slope's minus 12 over p squared times x minus x1 would be p. That's the equation of the line. We should clean it up a bit. And now I would look at what they gave us. Looking on the screen now, it has p squares on the bottom row. It has a p in the bottom row. Doesn't look dissimilar. They want y equals, so let's get y in its own. Y equals, and they don't want any bracket. So let's multiply this out. We get minus 12 over p squared times x. We get minus by minus plus 12p over p squared. And this guy would come over and we'd get plus, turn into a plus 12 over p. A couple of things here. This p and p squared, they'd cancel, or partially. The p would go into one of those p's. 12p and another 12p, they just add together. That's 24 p's. And that's exactly what they gave us. Y is equal to minus 12 over p squared x plus 24 over p. That's what they told us it would look like. That's how we do that part. Okay, C part 2. They talk about an area of a triangle. A triangle that's made by the tangent we were talking about in the last part. So imagine this is a tangent here. That makes a triangle with the x-axis and the y-axis. And we just don't know where this tangent could be here, could look like this, could look like this. So we could have lots of different types of triangles. And what's really interesting, I honestly find this question interesting, in that they tell us that the area of that triangle is K, no matter what it looks like. So whether it's, let's draw 3 triangles, whether it looks like this, or maybe it's a really tall and thin one, or maybe it's a narrow one of that. They're telling us that they all have the same area. What is the area? So let's just go ahead and try and find the area. We'll assume for our picture, it just looks boring like this. We have an equation for this line. Again, it might not look like that. It could be there, or really steep, or really shallow. But still, we'll just, for the drawing, we'll just assume that. That's similar to what they've given us as well. How do we find the area of a triangle? All I need to know is the height of it and the width of it. And the height would just be where just need this point. If I have this point, that tells me the height. If I have this point, it tells me the length to 0. And this equation tells me everything about that line. This point should be easy to get. It's the y-intercept. I've left an x out here. It's just when x is 0, what's y? So y equals 24 over p, or this point here. Let's draw a triangle again. That means this height here is 24 over p. What's the width? That's a little harder. It's when y equals 0. So we need to solve that. Let's see, minus 12 over p squared x plus 24 over p. When that equals 0, when y equals 0, that's when we'll get this point. So we just try and solve that, move everything around. We'll have minus 12 over p squared x is equal minus 24 over p. Minuses cancel. Multiply both sides by p squared, divide by 12. We'll get x is equal 24 over p squared on top, 12 on the bottom. Things cancel. P cancels with one of those p's. 12 cancels to that 24. We're left with 2p. X is equal 2p. But remember, that's this point. That means this length is also 2p. What's the area of this triangle? It's a half times the base, 2p, times the height, the perpendicular height, and this is a right angle, so we're set there, 24 over p. And look what happens, the p cancels. There's no p in the answer, there's just numbers, and the 2's cancel. We're just left with 24. No matter what this looks like, if it looks like this, this, or this, the area is always 24. And that's hopefully an interesting answer. And that brings us to the end of question 9. If you have any follow-up questions about any parts in that, please let me know in the comments below. I'll do my best to get back to you. Thanks for watching and have a great day.